Hello everyone, in this video we are going to learn how to find the valency of the first 20 elements of the periodic table using just your hand. So this trick can be very useful for you in the exams, and you can easily remember this technique with just your left hand. So let's get started. We will start to move from this line of the thumb and then move in the direction as shown. Now we will position the 20 elements in these lines of the hands, like here, 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 and so on. And during this travel I will assign the 3 resting points. This is represented by the red marks given over here like this, in here, here, and here. So as per the direction, we will now put the elements over here: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Since we do not have the paths or the line of the fingers for potassium and calcium, so we are putting on the edge of this palm. Now by drawing this path we can easily find the valency. Let's look the valency for sodium. So in this path the sodium is present here. Now the simple concept is that every element here will try to go on this resting place, this red mark. So how many steps are involved to go to that resting place? So that will be the valency of the element, and try always to choose the shortest path to reach this resting place. For example, the sodium is nearest to this resting place, so it will need 1 step to go to this resting place. So the valency of sodium will be 1. Since it is going backwards, or chemically speaking, sodium has 1 excess electrons, so it will tend to lose its electron and get to this state. So its valency is +1. Let's look at another one, which is chlorine. So in this picture the chlorine lies over here, so the nearest resting place is over here, so it will try to move 1 step to reach to this state. And electronically speaking, so chlorine wants to get 1 electron to reach to this state, so its valency is -1. Now let's look at carbon over here. So carbon has got 2 possibilities, so it can either go backwards for 4 steps, 1, 2, 3, and 4 steps to reach to this resting place, or it can follow the another path, 1, 2, 3, and 4 steps to get to this state. So if it tries to gain the electrons to reach to this state, then its valency will be minus. So if it goes back in this direction to reach to this state, so it has to lose the 4 electrons, then its valency will be +4. So it also explains the concept of tetravalency of carbon. So you can see easily that the valency of carbon can either be +4 or -4. Let's look at for nitrogen. So nitrogen is present over here. So nitrogen will tend to get 3 electrons to reach to this state. So 1, 2, and 3 step to get to this resting place. So its valency will be -3. But sometimes what can happen is that if it gets the favorable pressure and temperature, this can also go back to 1 step, 2, 3, 4, and 5 step to reach to this stable state. Then its valency will be +5. So nitrogen also has got the possibility of having 2 valency, which is -3 and +5. Let's look for potassium. So potassium is here, so it will try to go back to this stable state by moving 1 step, and it will try to lose 1 electron, so its valency is +1. And let's look for argon. So argon is present over here, which is already in this stable state, so it doesn't want to move anywhere to go to the stable state. It is already on the stable state, so its valency is 0. It need not move anywhere. If you have remembered the first 20 elements of the periodic table, and in exam it is asked, you can easily remember the valency just by looking at this picture. So thanks for watching and keep learning.